Hello, students. I hope you are in good health and enjoying lockdown period. So many students have sent me mails regarding some doubts in chemical bonding and molecular structure topics. Why do atoms combine? So students, today I have prepared a topic. I have already written this topic. So now I am going to make it clear how do atoms combine and what are the reasons behind it. So how ionic compounds means how chemical bonds are formed, means covalent and ionic bonds, what are their properties. So let us see what all these things are. So why do atoms combine? Our question is, why do atoms combine? Means there must be some inherent property, some desire, some attraction, some stimulus that compels the atoms to combine. So the reasons behind this are mainly, number one, you see, it is the tendency to acquire noble gas configuration or octet rule. According to octet rule, you understand that every atom tries to become stable. So it tries to fulfill its octet, or in case of helium, its duplet. So you see, this is the main reason. And the second reason is the tendency to acquire minimum energy and maximum stability. Because you note this point that whenever there is minimum energy level, then maximum stability is attained by atom. Now, when the atoms combine, what do? They form type of bonds, and these bonds are of different kinds. So whenever there is sharing of electrons, sharing of electron will lead to covalent bond, and when there is transfer of electrons, so there will be the generation of ionic bond. So these two main types of bonds, let us first concentrate on these two things. First we will discuss about ionic compounds. So ionic compounds are what? They exist as crystalline solids, and a very live example you have seen in your daily life is NaCl, sodium chloride, because two types of ions, Na positive and Cl negative, combine to form NaCl. So sodium chloride is the very good example of ionic compounds. And what are the properties? Let us see. They are crystallines, okay, and they are solids. If they are solids, it is clear that their melting points and boiling points are high. Why? Because the ions are held together by strong electrostatic forces of attraction. So if they have strong electrostatic forces between them, then a large amount of energy will be required to break the crystalline structure. Okay, so their MPs, melting points, and BPs, boiling points, are high. Now let us discuss one point. What type of variation in melting point is there in case of ionic compounds? Because MP, melting point, depends upon the charges on the ions and the ionic radii they have. So there is variation. Ionic compounds are generally soluble in water and other polar solvents due to high dielectric constant. Now students, I think these simple things are clear to you. It's a simple topic because some students were having doubts in this. Now you see, the solubility of ionic compound is due to larger electrostatic interaction between the polar solvents and ions. Fourth point is ionic reactions. The ionic compounds split up into oppositely charged ions, as you have seen in case of NaCl. Na is positively charged and Cl is negatively charged. So the ionic compounds split up into oppositely charged ions when dissolved in water. Next is electrical conductivity. If we talk about electrical conductivity of ionic compounds, they are good conductors of electricity in the solution or molten state. Remember this, because in this state ions become free to move. Now, sixth point is non-directional character. Ionic bond is always non-directional in nature. Now you see, in ionic compounds, each ion is surrounded by oppositely charged ions, uniformly distributed all around the ion, and therefore electrical field is non-directional. It has no particular direction. Second thing is, I think these things have made some points clear about the ionic compounds. Now let us talk about covalent compounds. You see, students, these are the compounds in which atoms are bonded by sharing of electron. For example, you have seen in methane. In methane, we have seen that valency of carbon is 4, and to fulfill its octet, it requires 4 more electrons. And hydrogen is having a single electron, but it requires another electron to fulfill its requirement. So what happens? They share the electrons and fulfill their requirements. So if there is a single covalent bond between carbon and second carbon, then that is a single covalent bond. If there is a double bond, that is termed as double covalent bond in triple. So this happens in single covalent bond is always found in saturated hydrocarbons, you have seen, and double bond in unsaturated, and triple bond also in unsaturated hydrocarbons. This you have already gone through. Now, next topic we are having is formal charge. Actually, most of the students, especially in the examination hall, get confused that how to find out formal charge. So according to NCERT syllabus, I will tell you it in a simple manner. Formal charge, what is it? What is the formal charge? Remember students, you know, in case of polyatomic ions, polyatomic means having many atoms. Polyatomic ions, the net charge is possessed by ions as a whole. Net charge is possessed by ions as a whole and not by the particular atom or ion. So net charge is the result of all the atoms or ions which are the part of that polyatomic ion. But it's possible to assign a formal charge on each atom. So how do we do that? First, we should understand what is a formal charge. You know, formal charge of an atom is in a polyatomic ion or molecule is defined as, note it carefully, the difference between the number of valence electrons in an isolated, or isolated means free, atom, and the number of electrons assigned to that atom in Lewis structure. The difference between number of valence electrons of that atom and the number of electrons as assigned to that atom in the Lewis structure. So its formula becomes then, formal charge is Fc is equal to V minus L minus half of the S. Now Fc you have, it is formal charge, and formal charge is equal to total number of valence electrons which are found in free atom. So valence electrons in free atom minus total number of electrons present at lone pairs. total number of electrons present as electron pair minus half of the total number of shared electrons. So here in this equation or in this formula of formal charge, we are going through number of valence electrons, number of lone pair electrons, and number of shared electrons. Now, students, we discuss the case of ozone O3. You know, ozone's structure, it is a resonating structure, resonance hybrid. So what we see here is there are 3 oxygen atoms and double bond between there is one double bond between 2 oxygen atoms and a single bond. And whenever there is a double bond, then there are 1, 2, 3, 4 electrons, and 4 electrons are here used in forming the double bond. So 8 are complete. Then there is single double bond, there are 2 electrons, you can say, and 1, 2, 3, 6 electrons are in the bonds, and here 4 to 6 electrons and 2 are consumed in the bond. So 6 octets are fulfilled in this way for particular oxygen atom. Now let us see here. In the case of ozone atom, central oxygen atom is marked as 1. Central oxygen atom is marked as 1. So it is 1. Now you see here, it is like this. It is like this. So, and then if it is marked 1, now we will discuss formal charge on this particular atom. What is formal charge on oxygen 1 of the ozone molecule? You know, it has 6 valence electrons. It has 6 valence electrons. In oxygen, you know, as the shell itself defines, 1s2, 2s2 and 2p4. So in the valence shell is 2s2 and 2p4. So there are 6 valence electrons. 1 lone pair is there. This is particular lone pair here. And 3 bonded pairs. 1, 2, 3. You know 3 bonded pairs. 1, 2, third pair. So 6 electrons are here. Now therefore its formal charge will be V is 6 minus L. L is number of lone pair electrons, that is 2, and then minus half of the bonded pair, means shared pair, they are 6. So total formal charge is, this is 2 3s are 6, 3, 6 minus 2 minus 3 means 6 minus 5, that is plus 1. Now oxygen atom marked as 2. Here you see, here what we have, number of valence electron, as already we have done, 6 minus lone pairs are 4, 2 and 2, 4, minus half of the bonded pair are 1, 2, 3, 4. So 2 bonded pair means 4 number of electrons. So it will become 6 minus 4 minus 2. 6 minus 6, that is 0. So in case of first carbon of oxygen, this was formal charge was plus 1. But in case of second oxygen atom, it was 2. Now let us see the case of third oxygen atom. So here are what we have. As we know, valence electron will remain same. So their lone pair electron are 6 and shared pair is only 1, 2 electrons. Means 1 pair of shared pair electron is there. So 2 electrons are there. So what we will do, 6 minus half of the 2, that is minus 1. So the formal charges on the oxygen atoms in the Lewis structure of ozone molecule are written as first of the oxygen, it will have formal charge of +1. Okay, and in case of the second oxygen it will have formal charge of 0, and in case of the third oxygen it will have formal charge of -1. So students, this was all about how to calculate formal charge in a very simple manner. So I hope you have enjoyed this session. Thank you.